Are you ready to try a problem involving kinetic energy? Here's one for you. Norbert's Mars rover, with a mass of 210 kilograms, is traveling on the surface of Mars at a speed of 6 meters per second. Zot's rover, with a mass of 170 kilograms, is traveling on the surface of Mars at 8 meters per second. Predict which rover has more kinetic energy. Then verify your prediction mathematically. You may now pause the program. So did you make the correct prediction? Let's double check your work. Solving for the kinetic energy of Norbert's rover, we have kinetic energy is equal to 1/2 times 210 kilograms times 6 meters per second quantity squared. The kinetic energy of Norbert's rover is equal to 3,780 joules. Solving for the kinetic energy of Zot's rover, we have kinetic energy is equal to 1/2 times 170 kilograms times 8 meters per second quantity squared. The kinetic energy of Zot's rover is equal to 5,440 joules. So, comparing the two values, we see that the kinetic energy for Zot's rover is greater than the kinetic energy for Norbert's rover. We now know that an object may possess both kinetic energy and potential energy at the same time. Let's go back to our example with the apple. Any object that rises and falls experiences a change in its kinetic and potential energy. Let's look at this energy transformation as I toss the apple into the air. When the apple moves, it possesses kinetic energy. As it rises, it slows down. Its kinetic energy decreases. Because the height increases, its potential energy increases. At the highest point, the apple actually stops moving. At this point, it no longer has kinetic energy, but it has maximum potential energy. As the apple falls, the kinetic energy increases and the potential energy decreases. No matter how energy is transformed or transferred, all of the energy is still present somewhere in one form or another. This statement is known as the law of conservation of energy. As long as you account for all the different forms of energy involved in any process, you will find that the total amount of energy never changes. In other words, energy cannot be created or destroyed. It just changes form.